hydraulic trainer. Yeah, like I explained in my previous classes, the hydraulic circuits are exactly the same like the electrical circuits. In a typical electrical circuit, you have the battery, the source of the power, and after that you have a fuse, and after that you have the breaker on off, and after the breaker you have the resistor or loads, and after the loads you have the negative cable returning to the battery. This is the typical electrical circuit. In a hydraulic circuit, you have exactly the same. You have the motor and the pump. This is the electric motor and this is the pump. Like I explained before in other videos, all the hydraulic units are composed for one motor, electric motor, AC or DC. That motor should be reversible motor. If the motor is DC, it's probably you need the reversible solenoid control box in order to change the direction of the motor. If the motor is AC like this, that motor should be three-phase in order to keep a reversible rotation. After that is the pump. The pump is connected directly to the shaft of the electric motor.
So on a boat, that would be powered from the generator?
From the generator or from the AC
power.
panel,
Okay.
shore power.
Yeah. Okay.
Okay, the motor receives the power and the motor drive the hydraulic pump, and the hydraulic pump have suction from the tank, from the reservoir,
Yep.
and discharge. The discharge goes directly to the supply manifold, and after the supply manifold feeds the equipment, the fluid returns to the return manifold, and the return manifold is connected with the reservoir again.
I don't see where the supply manifold connection's coming off of that.
Okay, let me explain that.
Oh, it's behind there.
Look,
It's behind.
this is the suction.
Yeah, that's the suction.
This
Here's
is the suction,
supply.
and this is the supply. Look, the supply pass through those check valves. This is a typical check valve.
Yep.
Equal like the freshwater system or electrical system. Okay, after the check valve, if we go in the back.
Yep.
After the check valve, that hose continue.
Yep.
Look, follow
Yep.
me, and the hose enter here, and this is
Our
the
supply manifold.
supply manifold. What is the other name for the supply manifold? Is the positive bus bar in the electrical
Yeah.
system. Is the positive.
So
bus
from
bar.
here, you're going to feed all your equipment.
Correct. Immediately you feed that manifold with constant pressure. This is the pressure produced for the pump and the motor.
Yep.
Okay, that pressure is on the gauge.
Okay.
And this is the pressure that I have to supply all the equipment. Doesn't matter if they are actuators or if they are motors or if they are relief valves. No problem.
So the size of the motor determines the pressure? The capacity of the motor?
The size of the pump and the motor determine the pressure produced for the system.
Okay.
Okay, this is the pressure produced for the system. This is the positive bus bar, and this is the gauge. This is the pressure gauge or voltmeter.
Yep.
This is the pressure gauge or voltmeter.
Yep.
That's okay.
Yep.
All right. After the supply manifold, the hoses goes out. That hose is marked red, and that hose enter in that relief valve or check valve or breaker. In the electrical system, you have a breaker. After the breaker, the fluid enter here, and the fluid goes out, and excuse me, the fluid enter here is coming from the supply manifold.
Right, because this is marked red.
Correct.
So that's going to come here. This is entering.
And this is the output.
Okay.
The output is coming from the output of the relief valve
Yep.
or sequence valve and enter in the discharge manifold. And the discharge manifold is connected in the back with the
Reservoir.
return into the reservoir.
Okay.
We have the pump. The pump supply the power here. After that, the power enter in the valve, in the valves, and the output of the valves goes into the return manifold, and the return manifold return over there.
So
And
I guess my question would be, why do you need, if this is, what are these other ones for? Is this supplying?
Because in this particular case, I am going to use this valve or this breaker only to supply power for this actuator. Let me explain how can you connect. Look, I am going to connect the double red in the bottom of the actuator.
Okay.
And I am going to connect the double red with yellow in the middle, double red with yellow in the middle on top of the actuator.
Yep.
It's supposed that if I start the system and I move the valve, the actuator goes up and down. Let me check that. Okay, the system is ready. And now, down or up.
Okay.
Or down.
So my question is, why do you need, if you're coming off the supply manifold into here, why do you need these other ones?
Okay, because from the output of the manifold, I can connect other actuator here, or can I connect other motor here?
But don't they need to run through this?
Exactly, because I need a valve. Let me explain that one. For
Okay.
example, I want to connect with the other valve. In the other valve, I am going to put a bow thruster. This is the bow thruster.
Okay.
Let me connect the bow thruster. I have other hose. I have another hose, yellow.
Yep.
And other hose, red, yellow. Okay, look at this. I am going to connect this one from this pine, supply manifold, and now, no, excuse me, from this valve, because right now I have fluid in this double breaker or double valves.
Okay.
Okay, I use one for one
This
actuator.
is the in and this is back to
and
the
this
thing,
is the
right?
input and this is the output.
Okay, perfect.
Okay, and now I am going to connect that one
Okay.
through that motor. One side of the motor, and the other one in the bottom.
So the input's on the bottom and then the output's on the
Doesn't
top?
matter.
Doesn't matter. It'll go either
Doesn't
way.
matter.
Okay.
And the other one on the other side of the motor.
Yep.
And right now I am ready to start the system and operate the motor in both directions. This is the bow thruster, and this is the joystick in the console. That's the joystick, and this is the bow thruster. What is the advantage of this bow thruster against the electrical bow thruster? That bow thruster can be used for a mega yacht because produce thousands of pounds of PSI, of force. The other one, the electrical, is for small boats. That's the big difference. For that reason, in cargo ships, in containers, in big boats, the bow thrusters are hydraulics.
So what about like in the mega yacht, the 200 foot hydraulic?
Hydraulics.
Okay. Because one of the guys questioned me that works at one of the yards, and he says
Hydraulics.
that they're all electric, he thought.
Hydraulics.
Okay.
Okay.
Is it a
Let-
combination of the two, or?
No.
Okay.
Oh, okay. The combination is the electrical, because the electrical use an electric motor and a hydraulic unit, like the bow thruster over there.
Yeah.
Is a combination.
Okay.
Okay. Let me explain something. We install in the supply manifold the pressure gauge. The pressure gauge is the voltmeter in the electrical system.
Yep.
Is the pressure of the system.
Yep.
But I want to know, like exactly the same like in the electrical circuits, I want to know how much gallons per hour or gallons per minute or of fluid require this equipment or this equipment. For that reason, I need connect the flow meter in order to know how many gallons per hour is the consumption of the system.
Yep.
The flow meter. The flow meter in liters per minute or in gallons per hour. That's it.
Okay.
Okay.
Actually, there's gallons per minute on the bottom.
Exactly. Gallons per minute in the bottom and liters on top. That flow meter should be connected exactly the same like the ammeter in the electrical circuit. If you remember,
series on
in
the
the
supply
electrical
line?
circuit, they are connected in series in the positive line or in the supply line.
Okay.
In this particular case, I am going to connect the flow meter in series. Look, this is the positive bus bar, and this is the line that enter into the
line.
breaker.
Yep.
Okay, I am going to disconnect that one. I pass here, and after that, I am going to connect other hose from the output into the valve.
Okay.
I am going to connect the hose right now. And now, I have a hose from this point through this point, through the bottom.
Okay.
And now, when I start the system, I can check how many gallons or how many liters is the consumption of the system. In this moment, it's 20 liters per minute, the consumption in the system. Okay, when I activate, probably increase or decrease. This one is dual function. I put the pressure gauge on top, and the flow meter in the bottom. In this moment, the system is producing around 300 psi, and the consumption is 20 liters per minute.
All right. Now, if you were running multiple things off of here,
Yeah.
you're only getting the flow with your current setup off of this output.
Correct.
Wouldn't you want to run the supply line through this on its way to here? That way, if you were running multiple, that would give you your true gallons for all of these combined versus just one.
Okay, in this particular case, the flow meter is dedicated only to this valve. And this valve is double. This valve is administrating the bow thruster and the garage door.
Yeah.
Okay, but I want connect the flow meter for all the equipments connected here. In this particular case, I need other extra feeding here and here. I don't have that.
I got you.
Yeah. In this particular trainer is limited
But if you
individual.
if you ran before you brought it into the supply, if you ran that through and then from here into the supply, you would know
correct.
like the total
yeah,
use,
you
right?
can connect exactly.
Okay.
Before of that and
Before
after
the
that.
supply- before the
Correct.
manifold.
Before the manifold.
Okay.
Yeah, this is other idea. Thank
Okay.
you. This
Yeah.
is other idea.
Yeah.
Okay. What is the meaning of those pressure relief valves? Pay attention. You remember that this system in this moment is producing 300 psi.
Yep.
Suppose that I have a system that produce no 300 psi, 1000 psi, 1000 psi, and I need connect and I need supply power for different equipments. One equipment with 300 psi,
Yep.
other equipment with 200, other equipment with 100.
So you got to divide. You got to
Okay.
divide it out.
In that case, I am going to use those pressure relief valve. What is the meaning of that? In this pressure relief valve, I put the input here from the manifold pressure here, and the output is 300 psi.
Yep.
In the second one, I put the input here from the manifold, and the output is 400
And are
psi.
these bi-directional also? Doesn't matter.
It doesn't, but normally the input is on top and
Okay.
the output is in the bottom.
Okay.
In some cases, they have the label in and out.
Okay.
But this is basically for that purpose. The name is pressure relief valve, and they have a different outputs according with the necessity.
Is that kind of like a voltage regulator?
Correct.
Okay.
Similar.
Yeah.
Or this one. This is a pressure relief valve that you can administrate how much pressure you want in the
Nice.
output.
Nice. So it's
Yeah?
a manual.
It's manual. This is a pressure relief valve manual, and this is a.
And what do you got? One supply line on the bottom and then two coming out, or how does that work?
It's basically input out, and this is the output that you wanted. This is in and out from the manifold, and this is the
So where does the output go? Back to the tank?
to the tank.
Okay.
To the tank.
Okay. So it allows some to pass, but it allows a certain amount to come through.
Correct.
And that's how it regulates the
Correct.
the
For
pressure.
that reason, you can regulate here more
Cool.
or less.
Nice. And whatever it doesn't use, it sends through the ground back to the battery and like
Correct.
a electric.
Correct. In other cases, you need a flow divider because you need to activate two cylinders with the same pressure. You enter here, and from each output you feed.
That's like a
different
Y
cylinder,
connector.
Like a Y.
Yep.
You see, those elements
It's
are
simple.
exactly the same like
What
the
about the
electrical.
junction manifolds?
The junction manifold is basically you can
Like a
extend.
supply.
You can extend the supply manifold or
Okay.
the return manifold with other than this.
Okay. If you had small stuff to run. or
Correct.
something.
Correct.
And then could you like supply to here, and then have your output?
Correct.
And then you have your outputs, and then could you put
You multiply
run
more.
them into relief valves depending on what the pressure you're
Correct.
trying
Depending
to
of the
do. So
dimension.
you can fine tune it.
The only that you need is be organized and mark the hoses, the beginning of the hose and the end of the hose with the same label.
Yeah.
In order to avoid confusion, because when you have all the hoses connected, it's confused for you.
So you did go over the spool directional because that's the same as here.
Correct.
This is the same.
This is single.
A single.
And this
okay.
is double.
Okay, good.
You can use that one or that one.
And then the
Actually,
sequence valve.
and the sequence valve is similar to the flow divider.
Okay.
I
All right.
appreciate it when you finish the laboratory, you disconnect the hose and put the hose in the back properly rolled,
Yep. Okay.
properly organized, and put the laboratory the stand here.
Okay. Awesome.
But
Thank you.
it's a wonderful
Yeah,
trainer.
it's beautiful. It's
It's
nice.
a beautiful trainer. The system is working properly. mount thruster, actuator, flow meter, pressure meter.
Okay.